And we are now live, and we are very privileged to have a special guest with us today. This is Dr. Stofan, who is not just any person from NASA. Dr. Stofan is the chief NASA scientist. Notice A, she's a woman, so all the young ladies over here, you can go right to the top of NASA, especially if you are a big maths and science fan. And not only that, she's also a very, very nice person. And she knows all about what's going on in NASA. And as you know, there have been some recent developments with regards to Mars, and we're certainly going to be talking about that, because they found something special on Mars that they've been looking for a long time. And we want to know all these sorts of answers to all our particular questions. So I'm not going to stand in the way. I want you to be able to see them as well. Louise says I'm very hard to hear when I face the audience. But can you hear me now, Louise? Please, hopefully we'll get a nod of the head. Yes, they're nodding of the head. Okay. So let me begin by asking you, you've obviously, I mean, you're now the chief NASA scientist. How did you get into space science, and how did you work your way all the way to the top?
Well, I have kind of an unusual story, because actually my father worked for NASA. So I went to my first rocket launch when I was 4 years old. And so I was always interested in science. And when I was a kid, I always loved to pick up rocks. So I would go around and pick up rocks. I loved outside. I loved going for hikes. And my mom was a science teacher. And when I was about 12, I went on a field trip with her. And she had a geologist. She was taking a geology class, and I went along with her on the field trip. And I realized people got paid for a living for going around picking up rocks. Do you believe that? I mean, here was something I enjoyed doing, and it was actually a job. But then when I was about, I think I was about 14 years old, NASA launched a mission to Mars called Viking. And when that mission was going to Mars, because my father was involved with the rocket launch, I got to go and hear all these scientists talking about why we explore Mars, that it was this amazing red planet that had dried up rivers across its surface. And I thought, geology, space, wow, you can put those two together and make a career out of it. And so that's what I did. So I went to college and majored in geology, studying mostly the geology of the Earth, how did the landscapes around us form. And then I went to graduate school and got a doctorate degree, and I studied for my PhD, I studied volcanoes on Venus. And Venus was really an amazing planet, which if anybody has any questions, I can talk about Venus forever. And I worked on a bunch of different NASA missions after I got my PhD, just kept working hard, learning all kinds of cool things about Venus, about Mars, about one of Saturn's moons called Titan, another one of my favorite places in the solar system. And eventually they said, do you want to come and be chief scientist of NASA? And so now I have the most fun job in the world, because I get to advise the NASA administrator. He's the big boss of NASA. I get to advise him on policy all across science. So not just about geology, not just about our solar system, but about the science we do studying the universe, the science we do studying the sun, and even more importantly, the science we do studying our own planet Earth. So that's my story.
Wow. I mean, it's not like you would turn down a job when you get offered an opportunity to work for NASA. Wow. I'm going to try and speak to the computer, because some of them were saying that when I face the audience, they can't really hear me. So now you are in this very important position where you get to advise Commander Bolden on all matters relating to science. And of course, NASA is moving in new directions. And one of the interesting things that has happened is, you know, the moon got a lot of coverage back in the 60s, and it was all the rage. But now Mars is obviously taking center stage. We've had quite a few missions to Mars, not sending any human beings, but certainly sending Mars rovers and that type of thing. And then recently, there was a little bit of an announcement. Now, before I go into that part, you were in Cape Town a couple of months back, and as soon as you left Cape Town, you made a prediction. Do you remember what your prediction was? What was your prediction that caused absolute chaos and mayhem all over social media, you said something about life on other planets. Can you just remind us what that prediction was?
I did, and I must say I didn't really mean to cause mayhem, but it clearly did. What I said was we were having a press conference talking about all our recent discoveries on how we keep finding water everywhere we look, whether it's water on Mars, water at Jupiter's moons that have icy crusts with liquid water oceans behind them, and we were saying this universe, our solar system is much soggier than we thought. There's a lot more water. Water is really important for life. So what I said is I thought within 10 years NASA would find strong indications of life beyond Earth. Now what I meant by that was we would find chemical signatures, chemical imbalance that would be consistent with life having formed on Mars or Europa. And that in 20 years, so in the 2030s, we would find actual evidence of life, direct evidence of life beyond Earth. And by that I was thinking, if by that point we have humans on the surface of Mars cracking open rocks and actually finding fossils on Mars, or an advanced spacecraft out at Europa studying its liquid water ocean and seeing if life evolved, we're starting to look at planets beyond other stars, but we're still probably a good 20, 30, 40 years away from being able to really get an image of a planet that would tell us it has trees on its surface, you know, a green and blue planet, not just a blue planet. So we're a little further away from that. I didn't think that my words were that radical, but I certainly got a lot of attention for them.
I mean, I don't think it's radical, because from a probability point of view, there's a great chance that if you can find water on a planet, there might be tiny microbes or some sort of organism living in that water. So do you reckon we might find life on another planet purely based on the fact that we've now discovered water on Mars?
You know, that's really the idea, Steve. You're right, and the reason for that is, first of all, water has really unusual properties. Lots of stuff dissolves in it, and you say, well, why is that important? Well, life needs nutrients. It needs something to eat, and so the fact that all this stuff dissolves in water gives you a really rich environment. The other reason is we know life here on Earth formed in the oceans, and it actually remained in the oceans for well over 1 billion years. And we think that properties of the water molecule actually helped RNA and DNA and cells form. And so all that evidence together says where there's liquid water, that's the most likely place to go to look for life. It doesn't guarantee that life is there, but it's the place to go look.
But now, the fact that we've actually discovered this, there were obviously, I mean, surely scientists were thinking that there's a possibility that there would be water, and this means that obviously Mars is going to take more focus. Are you accelerating the Mars colonization project, or, I mean, in terms of your priorities, where are you focused when it comes to Mars?
Well, we certainly don't have a plan to colonize Mars. What we're trying to do with Mars is a really thoughtful program in terms of the science, and so far that program has been what we call follow the water. So it's been trying to say, where are the most likely places to go on Mars to look for those wet environments where there could have been life in the past. So that's what our science program, all of our different landers on Mars, our Curiosity rover right now in Gale Crater is studying this environment that was very wet in the past. And then eventually what we want to do by the 2030s is get humans to Mars to do that next kind of really detailed level of exploration. And we'd like to get humans safely landed on the surface, return them home again, and then do that multiple times and see how we go and see what we discover.
Wow. I mean, obviously the movie Martian is now making waves as well. Have you seen the movie?
I've seen it twice. We had 2 NASA showings for NASA people here in Washington last week, and so I introduced the movie at 2 different showings, and I actually got to be on a panel with the director and one of the stars of the movie, so that was pretty exciting.
That is very cool. And I mean, in terms of from a realistic point of view, what were your impressions?
I thought it was really fun. It's been widely reported you know, and I'm not giving anything away. The whole movie, it starts with this massive Martian dust storm that endangers them, and that's how this poor guy, it's no secret, the movie's about a guy who gets left behind on Mars. And so it's set up by this giant dust storm on Mars. The thing is, Mars has a really, really thin atmosphere. And it turns out, if somebody actually does the math, the wind would have had to been blowing well over 500 miles an hour, which it does not do on Mars. But okay, let's just put that opening scene aside. From that point, the movie gets a lot of the technologies we're working on right. It gets a lot of, you know, how you would do it. It gets the Mars geography right when they're going from one place to the other. They follow logic. And so that was the fun part. And frankly, the way the NASA people kind of act in the movie, I thought was also, you know, it was very fun and very realistic. So it's definitely fun.
So they never got anyone to play you in the movie. Is that what you're saying?
Definitely not.
No. and now, of course, if one had to take a look at NASA's track record over the past, let's say, 2 years, some major events have been taking place. You've had Horizon fly past Pluto, New Horizons flying past Pluto. You've had this big announcement of water on Mars. You've been landing little devices onto comets. I mean, it really has been quite a hit rate for you guys over the past 2 years.
No, it's been an amazing few years. You know, just this past summer, as you said, New Horizons going by Pluto, and I mean, I must say, I'm one of the people who thought Pluto would be really boring. I thought it would just be this kind of cratered world. It would sort of look like the moon, and it doesn't look like the moon at all. It's got a very young surface. It's bizarre. It's beautiful. It's really an exciting world that scientifically we don't understand why it's as complex as it is. And that's really fun, because when something's not what you expect, that's where you're really going to learn something. So we absolutely love Pluto. That same week as Pluto, our Kepler Space Telescope found a planet in the habitable zone where liquid water could be liquid on its surface, of an Earth-like star called Kepler 452b. Very far away, not something we're going to go visit anytime soon, but still amazing to think here is another Earth-like planet up there. Kepler has discovered over 5,000 planet candidates over the last several years. Can you imagine that? If you go out tonight and put out your thumb, you're blocking about the area of the sky that Kepler has been looking at. So in that small area of the sky, it's found thousands of planets. That says just about every star in the night sky has a planet around it, and that's amazing.
Wow. So, I mean, if we could develop spacecraft that could travel further and faster, and we could actually, maybe not in our lifetime, because, I mean, some of these planets are so far away, it would take a few thousand years just to reach them. If we could get there, there's a high probability, according to Stephen Hawkins, that there is indeed life on other planets.
Well, that's what we think. The problem is that's why we need all the kids listening here today to stay with science, technology, engineering, and math, because you know what? We haven't invented that really fast propulsion system yet. So you guys have a lot of homework to do. You need to work hard and figure out how can we develop a new generation, next generation engine that helps us go so much faster. You guys have work to do.
Yeah, lots of work. How cool is it to have astronauts all over the place wherever you work?
You know, it's really fun. It's amazing to talk to people who've been up in space. You know, it's such an amazing experience that they've had, and I get to hear all their stories, and I'm kind of a chicken, and so it's great to be able to kind of live vicariously through them. I prefer to stay down on the surface of this planet, but it's amazing to talk to people who've actually had that perspective. And you know, the one thing they always say is when you get up and you look at this planet from above, you know, you don't see borders. One country blends into the next, and you see how thin the atmosphere of our planet is. You see how fragile our planet looks, and it gives them a huge feeling of just what you know, we're all in this together. It's one planet, and we've all got to work together to make it a place that we all want to live.
That is amazing. Well, what I'm going to do And I can see we've even got some guests from India who've just joined us as well. I'm going to open the floor to some questions. And I'm also going to start off with, I know that Miss Morgan's group, they've got a space group that have been dying to ask lots of questions. So I'm going to unmute Miss Morgan, and we're going to hopefully get to hear some of the questions from their students. Miss Morgan, you can just unmute yourself, and then hopefully you'll be able to choose some of the kids to ask questions.
All right. Let's see. So we want to...
There we go. There we go. We're not hearing you, Louise. No?
You're not hearing us? Oh, no. Can you not hear us?
I can hear you.
Okay, wait.
Can you hear us?
We can hear you clearly, yes.
You can hear us. Okay, good. It seems like I've frozen up or something. All right, very good. Yesterday we sent some questions. I have them right here. Let me forward them to you. Okay. And then you can...
I did get the email, but maybe some of the kids want to ask the questions themselves.
Okay, sure. Mm-hmm. Do you have them? Oh, because I sent them to you. Yeah, that's right. Okay.
Did you send them to me? Yeah.
Okay. Hang on just a second. We have the list of questions, and we just want to make sure we pick. If you might...
We can give you a moment, or you...
Thank you.
Okay, we'll come back to you.
Thank you.
So I'll just put her on mute. Anyone in the audience that here want to ask a question? Yes.
Make sure you speak up.
Question. Dr. Stofan, the question was, have we ever found life on the moon?
You know, we haven't found life on the moon. We brought back lots of rocks from the moon. From the Apollo astronauts brought them back. And what we learned from those moon rocks was actually that the moon used to be part of the Earth. And very early in the history of the Earth got hit by something really big. This was back over 4 billion years ago. The Earth got hit by something really big, tore a chunk of it out, and that's what the moon is made of, which is an amazing thing. So we've certainly, the moon at that point, the surface of it was probably molten. It was all melted. So it was very hot on the moon, so nothing could have survived that. And so even if life had been around at that point, which it wasn't, life evolved on Earth about 3.7, 3.8 billion years ago. So the moon formed before that. And the moon never had an atmosphere. It never had liquid water on its surface. And so we've found no evidence of life at all.
No evidence of life at all. Okay. Louise, are you ready with your questions? Let's unmute you. Let's have a look. You're going to unmute yourself. We've got no sound from you yet.
Can I say my question?
Here we go. Here we go.
When do you think astronauts are going to be able to go to Mars?
Well, right now, we think astronauts will be ready to go to Mars around 2030, sometime in the 2030s. Probably not about the middle 2030s, and we're still working on what that first mission to Mars would look like. Would we just orbit Mars the way we first did when we went to the moon with astronauts? First, we orbited them around Mars and then brought them home, and we did that before we ever tried to land them on the surface, just to make sure we understood all the risks and we could keep them safe. So we're still working on, in the 2030s, what is the exact plan? Should we orbit first? Should we land on one of Mars's moons? Mars has 2 moons, Phobos and Deimos. Should we try landing on one of them? It's a lot easier than landing on the surface. Entry, descent, and landing on Mars is the hardest part because Mars's atmosphere is thin, so you have to slow your spacecraft way down. So we're still working on a plan, but I would like to see us get humans onto the surface probably about the late 2030s is what we're thinking right now.
Which would mean that obviously the kids right now are at the right age to be the astronauts who will be landing there.
That's right, and you guys are exactly the right age. And the other thing to think about is if you're thinking, Well, if I don't live in the U.S., this isn't a thing for me. You know, that first crew to Mars, it's going to be hard to get to Mars. And we're already working. We have 16 space agencies from around the world that are working on something called the Global Exploration Roadmap. And so as part of that, it's very much certain that that first crew to Mars, every crew to Mars, will be international. It won't just be people from the U.S.
Okay, now before we get another question from Ms. Morgan's group, Atalo from Brazil, you have someone who wants to ask a question, so just unmute yourself.
Okay, Yasmin is going to ask the first question. Go, Yasmin.
What's the special garbage composed of?
Did you listen to that?
No, I couldn't understand.
What's the spatial garbage most composed of?
A special what composed?
Spatial trash, garbage.
Oh, what kind of
trash.
Are you asking what kind of trash we have in space?
Yeah, that's right.
Yeah, okay. Well, we have a lot of trash in space because the astronauts, we have 6 astronauts living up on the International Space Station. So, of course, they generate trash, right? So, I will tell you one thing that doesn't go into the trash. We recycle about 85% of the water on the International Space Station because water is heavy and you don't want to have to bring all that water from the Earth. So think about it. Everybody knows you can figure out where we get water from and what the astronauts are drinking. Yuck. We clean their pee and they drink it. So, but it's clean. By the time they drink it, I know you guys will go, oh! So that's one thing we don't throw away. The stuff we throw away, believe it or not, we throw away their clothes because there's no washing machine. Remember what I just said about water being such a precious resource? We don't have washing machines. So they wear their clothes for over a month, and then we throw the clothes away. We have food trash that they throw away. You can't recycle up on the space station. So we have all kinds of different kind of typical trash, and it actually gets packed into containers. Sometimes the big trash we put into some of the cargo vehicles that come up to the space station. They bring supplies. We put trash back into them, push them off the space station, and they burn up in the atmosphere. So all the trash from the International Space Station actually gets burned up in Earth's atmosphere.
Wow. Okay, we have another question from the audience here, and then we're going to leave your hand up. Yes? Why was it waving? Is that what you want to know? Oh, this is a good question about Neil Armstrong on the moon, and the flag was waving. Apparently, he wants to know how is that possible?
You know, the flag wasn't waving. The flag had, you know, wires in it to make it stand out straight because we know there's no wind or, you know, no atmosphere on the moon. So if you put a flag, it would just go floop and you wouldn't be able to see it. So they made the flag so that it would be rippled and straight out. So they had to unroll it so that it would stay out. But it was made so that it would look like it was waving in the wind. But there's no wind on the moon. When they took off, there are some videos of when the lunar module took off, the flag got battered by the force from them taking off in the lunar module. But the flag, that was not a flag waving in the wind.
And you guys have just released a whole bunch of photos, several thousand, if I might be correct, in saying about the whole moon landing. Is that correct?
That's true. You know, we have so much data that had never been released to the public, not because, you know, just because there was so much of it, so many photographs taken on the surface of the moon. And we've been spending time, you know, at some point all of this was literally photographs on film. And so over the years we've been, to preserve it, we've been transferring it to digital, and then as we do that, we release it. And so this was just a whole bunch of film that had finally been put into digital form, and so we could get it out there to the public in a way that they can easily use it. Anybody had been able to come and look at the photographs before, but that's not useful. Now everybody can see it on the internet, so it's really great.
Awesome, awesome. Now we're going to switch back to Louise's class. I know that they've got some more questions.
What has been your best experience so far?
Oh, Let's see. You know, my best experience so far is last year as chief scientist. I got to go down with an aircraft that we have. NASA just doesn't use satellites to study this planet. You know, climate change is something we're really concerned about at NASA, and we're making all kinds of measurements to try to understand how our planet is changing. And most of you know it's getting warmer because of greenhouse gases in the atmosphere, carbon dioxide and methane that humans produce. And so one of the things I got to go to last year was I got to go and fly with one of our NASA aircraft that was studying the ice sheet in Antarctica. So we flew the airplane from Chile down to Antarctica. We descended to, you know, not very far above the ice sheet, and we flew over the ice sheet making measurements for about 3 hours. And it's beautiful. Antarctica is amazing. It's just this vast ice as far as you can see, but sculpted by the wind. Very, very pretty. The sad part is what we're finding is in that part of Antarctica, in the western Antarctica, the ice sheets are melting because of climate change. And in fact, with our measurements, we've been able to see that the ice shelves in that part of Antarctica are moving towards the ocean, and they're going to contribute about 1 meter to sea level rise. So it's something we're really worried about, and that's why we keep sending our instruments down there to study the ice down in Antarctica, but also up in the Arctic, where we also know there's been a lot of ice loss due to climate change.
Okay. I'm very keen to maybe hear from Suresh from Nepal. Suresh, if you want to unmute, do you want to ask any questions? Or would you like me to read one of them from the list of questions that you submitted? You're just going to have to unmute yourself. Click on the little microphone. Okay, we can't hear you.
Oh, you did the relevant marker.
Sorry.
I think. Okay, try it now.
A little glitchy here. Sorry.
Do you know about SSEP, and do you think it's good, like a good program?
No, SSCP I don't.
Tell them what it is.
Well, SSEP is, well, we do this in science, and it's like with math too. We go into groups and we do experiments, such like my group is going to do like an experiment, let's say, on how carbonated drinks reacts in space. And we just see how it react on Earth, and we investigate more about it. And that's pretty much what it is.
You know, I love any kind of like that. When you guys actually are doing experiments that we can compare to what's going on up on the International Space Station. We learn so much about how materials behave, about how fluids behave, about how our human bodies behave when you go up into space and you don't have the gravity field that we have here on Earth. Everything behaves differently, and when you find those differences, you can learn a lot. For example, with fluids, it's really important because there's lots of forces on fluids, for example, when they're going through a pipe. And you might say, well, does that affect me? Well, your water comes to your house in pipes, sewage goes out of your house in pipes, and so understanding how that fluid is flowing through that pipe helps us make our cities work better. So the more we understand all the forces on those fluids, the better we can make our cities work. And so when we go into microgravity and study things, it really helps us understand how to make life here on Earth work a little better. So the kind of experiments you're doing, where you get to be the fun scientist, you know, we try to keep it a secret, but being a scientist is actually really fun. You get to do all kinds of cool stuff. So you're doing just what the astronauts up on the space station do. You're conducting experiments, trying to figure out how things behave, and then doing comparisons. How does the Earth compare to space? So I think it's great. That sounds really exciting.
Awesome, awesome. And then we're going to switch to Mrs. Smith's class in Chicago. Maybe they want to ask some questions. Do you want to unmute yourself?
Muted. All right, we're unmuted. I'll send one up to the camera to ask a question. This is Austin. He's going to come right by the camera.
Hi, I have a question.
Come down a little bit lower, Austin. Come down a bit lower.
Can't you make life on the moon since there's the polar ice caps?
You know, that's a great question. You're right. We have found ice at the poles of the moon. we think that ice got there probably through comets impacting onto the surface of the moon. You know, comets are big ice balls. Some of you may have seen the great images from the Rosetta mission, which is a European Space Agency mission of the comet 67GP. I always forget. It's got a really complicated name. I can't. There you go. Thanks, Steve. So comets impacting on the moon brought ice there. We know from studying comets around the solar system that they have really complex organic molecules in it, things called amino acids that are the building blocks of life here on Earth. So probably what we would find if we could analyze that water on the moon is we'd find some of the building blocks of life, but because there's no liquid water and because the temperatures are very cold on the moon, those building blocks wouldn't have been able to do all the chemical reactions that would lead towards life. But that doesn't mean it's not interesting to study, because we'd love to study those early phases. How did you go from building blocks to life? So it's something we definitely want to go look at.
Okay, I know we had some more questions from Atalo in Brazil. Do you want to read out the question?
Okay, Klaus has a question.
What food do you astronauts in space
Eat in space. What food?
That's a great question, because, you know, astronauts want to eat just as good food as we do here on the ground. And that's kind of a problem sometimes, because, you know, they're going up there for 6 months at a time. We've got 2 astronauts up there right now for a whole year. So the hard thing is getting them fresh fruit and vegetables. So we have to send those up from the Earth in a cargo vehicle. And fresh fruits and vegetables help keep astronauts healthy. So one of the things we just did this year as an experiment is we've actually started growing food up on the International Space Station. We had an experiment called Veggie. We grew lettuce up on the space station, and the astronauts ate it. And the reason for that is, again, fresh food actually helps keep human bodies healthy. And if we go to Mars, which takes 8 months to get to Mars, 8 months to get back, that's a long time. No way you're going to keep fruit and vegetables fresh for that long. And so this veggie experiment we were doing was getting ready. How can we grow food in space, healthy food, to help astronauts on the journey to Mars? Other than that, the astronauts generally eat kind of packaged foods. It's all kinds of different kind of food. They have it kind of mushed up in these little plastic packets. Frankly, it doesn't look incredibly appealing, but the astronauts say a lot of it is quite good. They take candy up with them. They play games all the time. You can see in microgravity, they're always playing games with candy. And most recently, their exciting thing they got was a coffee machine. They got an espresso machine up on the space station. So they have all kinds of stuff up there.
That's pretty cool. Now I know Suresh in Nepal, he's going to ask a question. So you can just unmute yourself. Okay. We're not getting any sound? No sound? No, we're not getting any sound. So, Suresh, you'll have to type your question because we're not getting any sound from you. Your audio is not working. Okay. Let's just go back to our audience over here while Suresh sorts it out. Any other questions you guys want to ask? No? Anyone else? Okay, we'll go back to Miss Morgan's class.
Great.
Okay, there you go. See yourself.
What planet do you think will be explored next?
That is a great question. You know, we're still exploring Mars. You know, that's one of our prime things that we're exploring. But the mission we're excited about that we're going to do next is going to Europa. Europa is a moon of Jupiter. It has an icy crust. Underneath that icy crust is a liquid water ocean. So here I am back to this liquid water thing again, right? Maybe could there be life inside Europa's oceans? The problem is it has this thick icy crust. And so what we're hoping is there's some places where maybe that ocean is very close to the surface or breaking out onto the surface or maybe erupting out into space so that we can actually study that liquid water ocean to see if there's any signs of life. So that mission will launch in the mid-2020s, and hopefully then at that point we'll be able to see, does Europa potentially have the be another place in our solar system where there could be life.
Okay, good question. Maybe we're going to switch to Livingston out in Kenya. Do you have any question you'd like to ask? Just unmute yourself.
Actually, I have no question because we have students around. I will prefer students to ask the question most because they are at the right stage to study a lot about NASA. So it's us. So thank you, Steve.
You're welcome. You're welcome. Okay, we like to put people on the spot. We like to put people on the spot. Sebastian, have you got a question you want to ask? You can just shake your head or nod your head. No? I do have some questions that were asked by the people in Nepal that it was listed on, let's see if I can find it here. It was listed on the site here. The one person wanted to know, what scientific research are you most excited about at the moment? And this was Fiona Riches through the Nepal Astronomical Society.
You know, I think what we're the most excited about at the moment is this whole growing field of exoplanets. I started talking about those 5,000 planets that Kepler has found. So with ground-based telescopes, we've done some observations of some of the biggest planets, and some of them we have found, even with a couple of our space-based telescopes, we have seen water in their atmospheres. In about 3 years, we're going to launch the James Webb Space Telescope, which will start studying the atmospheres of some of these extrasolar planets. So what are we looking for? Well, we're trying to figure out, are they habitable or maybe inhabited? So we're going to be looking for gases that we find in Earth's atmosphere, things like carbon dioxide, methane, water vapor. So we're going to be looking for all kinds of gases in those atmospheres that might tell us, well, this planet has the potential for life. The other thing you look for is you look for imbalances in the atmosphere. Is there an awful lot of one gas that tells you there's some kind of reaction going on, whether it's life causing that reaction or maybe volcanoes, you're not going to know, but at least you know, okay, that planet has some activity on it. So those are the things that we're going to be doing with the James Webb Space Telescope. Eventually, like 20 years from now, we want to get really big telescopes out in space that could actually image planets around other stars, but we're still a bit far from that. But to think that we go from studying what is the atmosphere of Jupiter like, what is the atmosphere of Venus like, to what is the atmosphere of Kepler 452b around another star like, that's amazing. We're really entering this amazing time period of starting to be able to study planets around other stars the way we study planets in our own solar system. So again, that's all going to be happening when the kids on this call are growing up. You're going to be not just our solar system planetary scientists, you can be planetary scientists of the galaxy, of the universe.
Okay, and now Suresh has typed in a question. It was from one of his members, Shulav Neopani, I hope I've pronounced it correctly. And he says, how big an effect does the discovery of water in Mars have on NASA's future exploration missions? And will there be more funds going into taking a team of astronauts to Mars? I mean, does this become a motivation to increase the budgets?
I can't speak for our stakeholders who determine our budgets on what motivates them. So, but I think the exciting thing for us is it certainly confirms a lot of what we believed about Mars. You know, there were people who thought, is it possible that life could currently exist on Mars? Now, the idea is, you know, liquid water disappeared off the surface about 3 billion years ago. So presumably any life on the planet died out at that time. But what if it went underground as the water froze and the oceans died up? Could life have gone underground on Mars? Here on Earth, we have life in very extreme environments, in places that have radioactive waste, in very cold places, in very hot places. So life can be pretty tenacious. So I think one of the things, when we now know there's at times liquid water running on the surface of Mars, it starts to bring up that question again in our mind of, could life still currently exist on Mars? Now that actually provides a challenge as well as a benefit, because we certainly wouldn't want our astronauts to be exposed to any Martian life before we understood if it was safe or not. So there's a whole field called planetary protection, where we think about how do we keep astronauts safe from any Mars life till we can study it, and how do we make sure we don't contaminate Mars with any bacteria from Earth, so that we can make sure if we find life on Mars, it's really life from Mars and not life we just accidentally brought from the Earth.
Wow. All right, we're going to switch again to Miss Morgan's class. I can see that they have a question.
Does Mars have an atmosphere able to sustain life?
You know, Mars does have an atmosphere, but Mars lacks a magnetic field. And the Earth has a very strong magnetic field. And it actually helps protect our atmosphere from the solar wind. So the sun has explosions on its surface all the time. They send particles streaming towards the planets. It's called the solar wind. That solar wind, again, it kind of bows around the Earth because of our protective magnetic field. Mars used to have a magnetic field. It doesn't have one anymore. So when that solar wind comes streaming towards Mars, it's actually stripping the top layers of its atmosphere away. So over very long periods of time, Mars's atmosphere has gotten thinner and thinner and thinner. So it has oxygen, carbon dioxide in its atmosphere, but the atmosphere is too thin, and a human could not survive on the surface without staying inside a spacesuit and a helmet. There's debate in the scientific community about whether you could do something called terraform Mars, which was a science fiction concept that people have written scientific papers about. Is could you cause some reactions to take place on Mars that would make its atmosphere much more dense and make it inhabitable, so humans could walk on the surface without spacesuits? But we're pretty far away from that, and by pretty far I mean thousands of years away from that.
Okay, now we're going to switch to Miss Smith's class. I think they might have muted themselves. You might have to unmute yourself, Mrs. Smith. There we go.
No, I'm trying to unmute. There we go.
Got it.
Okay.
So, how do astronauts drink water in space?
You know, they drink through straws, basically, because if they have water in little pouches, like kind of like a drink box or a drink pouch here on the Earth, and they drink it through a straw. And every once in a while, you can see they do funny things, like they open their mouths and allow water to come out. But when they do that, or they squeeze it and they let water come out, but of course when the water comes out, it doesn't spill onto the ground because there's no gravity. Instead, it actually forms spheres, so you get water balls that are basically floating around in microgravity. It's really fun. They play games with water on the space station.
Very cool. And Atalo in Brazil, would you like to ask a question? No. You have a question? Yes. Before Atalo asks the question, we just got one local question here. Yes. Okay, so the question was, besides the main reason of actually looking for life on other planets, is there any other reason to go out and spend all that money looking at other planets?
Well, you know, every time you said, that's a great question, and I think, you know, a lot of us do want to explore for the science to gain knowledge. Other people want to explore because they say it's just part of human nature. What's over the next hill? What's in the next solar system? But one of the things that I think is the most important to remember when you think about space exploration is that every time as a society, as a country, as a planet, we set a really hard goal for ourselves, like landing someone on the moon, like landing someone on the surface of Mars. You have to invent new technologies. You have to come up with new materials. You have to come up with better understanding of human health in space. All of those things end up hugely benefiting us here on Earth. And people have actually estimated for about every $1 US that gets invested in NASA, about $4 US are returned to our economy, because, you know, we don't actually spend the money in space. We spend it here on Earth. And it's great science, technology, engineering, and math jobs where we invent things that have all kinds of spin-offs that benefit us from, for example, the imaging that we do now to find breast cancer is based on imaging that NASA developed, to new materials that show up in your house or in any high-tech equipment. All of those are based on things that started at NASA. And we even do that with airplanes. That first A in NASA is actually aeronautics. And we still do aircraft research to make aircraft safer and more fuel efficient. And so NASA is always trying to say, how can we benefit life on Earth by looking beyond Earth?
So are you telling me I got it wrong? So it's not the North American Space Agency. It's actually the National Aeronautical...
National Aeronautics and Space Administration.
Wow. So I got it completely wrong. Well, see, I'm learning all the time, and I'm willing to admit that even I can learn new things every day. So now we're going to go back to Atalo in Brazil, and then I know that Miss Morgan's got another question, and then hopefully we'll go back to Miss Smith again. So Atalo, have you got a question?
Earth.
Okay.
How does a spaceship come back to Earth if it's on space and there is no materia there? There is no... Did you get that?
Yeah, I got it. All right. How does a spacecraft come back from space? Well, when we bring spacecraft back, for example, when we had a spacecraft, you know, every time when the space shuttle used to come back, when the space shuttle would go back up into space and come back, the space shuttle or any spacecraft that we want to come back actually has engines on it. And we use a fuel that's a combination of hydrogen and oxygen, and we fire the engines on it, and you have to make really complicated math. Some of you probably think that math is just math, but we use math for kind of cool things. You wouldn't be able to go to space or get home if it weren't for math. So we think about the Earth's gravity, how fast the spacecraft is going, and we fire the engines and point it towards the planet. Now, believe it or not, that atmosphere around a planet has some amount of density. And so you want to be careful that you come into a planet at the right angle. So you make it through the atmosphere. Because if you come in at too shallow of an angle, you could actually skip off the top of the atmosphere and miss the planet altogether. That would be a bad thing. So we have to do our math really carefully to make sure we get where are we going, are we firing our engines correctly to re-enter the Earth's atmosphere. Now when you re-enter an atmosphere, you're going through the atmosphere and your spacecraft heats up because of friction forces. All that air rushing by the spacecraft causes it to heat up and heat up and heat up. So we have to make anything that we want to bring back to the surface of the Earth, we have to make it out of very special material that can withstand very high temperatures. As it comes down, it slows down, cools down, and we can use the density of the Earth's atmosphere to help us slow down. And then we use parachutes to really slow it down, and then we land on the surface of the Earth.
Wow. Sounds like quite a complicated process. But now we're going to go to Louise.
Steve, I just wanted to thank you and scientist Ellen Stofan for doing this. This has been such a great opportunity for our STEAM students. We're going to ask one more question and listen to the answer, but then it's time for us to start school. But we really appreciate the opportunity to be part of this today.
Since Kepler found thousands of planets and there's like thousands and they're amazing, what's yours? What is your favorite planet that Kepler found?
You know, my favorite really is, that's a great question, my favorite really is this new planet that we found, Kepler 452b. Because the star it's around, you know, stars are all different. Some stars are much bigger than our sun, some stars are much smaller than our sun. And Kepler 452b is around a star that's kind of like our sun. It's the same kind of star, it puts out about the same amount of heat and light. And Kepler 452b is sitting right where water could be on its surface. But you know, right now we can't take a picture of its surface. We can't measure its atmosphere yet. And so we're really wondering, is it a blue watery planet like our planet? Or is it going to look like Mercury or Venus and just be all rocks and covered with impact craters? We just don't know. So right now all we get to do is wonder about Kepler 452b. Hopefully the James Webb Space Telescope might be able to look at its atmosphere, and then someday, maybe in about 20 years, when you're a planetary astrophysicist studying planets around other stars, you'd be able to actually take a picture of Kepler 452b and say, wow, not only is it a blue ocean planet, it's got land, and some of that land looks like it might have forests on it. So that's something we're looking forward to in the future, but that's still pretty far away.
Very cool. I mean, now, if New Horizons took 9 years to reach Pluto, how long would it take for us to get a flyby with Kepler 452b?
We're talking, at the current technologies, we're talking tens of thousands of years. And that's the problem. Our propulsion technologies are they're just too slow. We haven't invented warp drive yet. So that's why I'm giving that as an assignment to your students to invent the next generation of engine.
We're working on it, definitely working on it. Now, I know that Mrs. Smith's group might want to ask a question, and then maybe Mr. Soskill, who's just joined us, I think his students were Skyping an aquarium somewhere else in the world, and then hopefully they might even have a question. But Mrs. Smith, you want to...
Yes, we have another question.
Okay. Hello, my name is Carla, and my question is, what does the non-gravity have an effect on the human body?
That's a great.
If we have,
she's gonna answer.
The body, when you get the body out of gravity, awful things, I have to tell you, start happening. Our immune system that keeps us healthy doesn't work right. Our cardiovascular system, our heart and lung system, doesn't work quite right. You lose bone density, so our bones actually start becoming thinner, and we lose material out of them. Your muscles start wasting away. So our bodies are perfectly tuned to live right here on the surface of the Earth, and you take us out of that environment, and your body doesn't work as well. So you could say, well, the easiest thing would be just don't go into space, right? But is that a good answer? No. We want to go to space. We want to go to Mars, and it takes 8 months to get to Mars. So what NASA has been working on up on the International Space Station is how can we make all those effects less? How can we keep astronauts healthy? So we found out that through diet, through exercise, we can keep astronauts healthy. In fact, now we send astronauts up to the space station. When they come home, they have about the same bone density as when they leave, and it's from all that exercise. So we really have worked hard to say, how can we mitigate or lessen those effects of space and keep astronauts healthy? At the same time, that actually helps us here on Earth, because some of those effects I talked about, bone density loss, muscle wasting, happen to people as they age. And so if we can help prevent some of those effects in space, we're learning how to prevent them better here on the surface of the Earth.
Awesome, awesome. Now, I know that Mr. Soskill's fourth graders have just walked in. We can try our luck. Mr. Soskill, do you think any of your students might want to ask a question?
Hey, does anyone have a question? Yeah, go ahead, Eli.
And on Mars, how did they find the rushing water? Did they like dig deep, or was the water like on the surface?
You know, that's a great question. The water was on the surface, and the way we found it was not by finding the water directly itself, but what we saw were there are these streaks coming down a very steep slope, and what we observed is as those streaks went into summer, they grew longer and longer. And so the fact that the streaks were growing longer when the sun had been shining a lot on that slope made us think, well, the most likely explanation is water. But we still didn't have proof of it. So what we did is we used a different one of our instruments that's orbiting around Mars, and we measured the chemistry of those streaks. Were they just plain dirt? Were they different from the dirt around them? It turned out those streaks were actually salty, and they had a chemical called perchlorate, which is a complex chemical that we do find here also on the Earth. And so what was happening was this water that was more almost briny, so it was almost like a salt water, was picking up chemicals as the ice melted. It would pick up chemicals and it would carry those nasty chemicals down slope with it. So we were seeing the signature of what was being carried by the water, and that chemical signature would move down slope as the water moved down slope as the ice melted. So it wasn't a direct measurement of liquid water. It was a measurement of the stuff the water was carrying. So it was nasty water, not water you'd want to drink.
No, definitely not. Now, I know that there was a question from Nepal, and it was about how NASA sees the opportunity to motivate young students from developing nations like Nepal, which has no space agency for future exploration missions. So how does NASA go out and promote the whole excitement? And I know that Tyler from Brazil also has to go, so we'll say goodbye to him. But how does NASA promote young developing nations in terms of getting them excited about science, maths, and especially space science?
Well, you know, one of the things in Kathmandu, we actually have a program going on that is called Servir, which is from the Spanish verb to serve, where in different places around the world with the U.S. Agency for International Development, we have offices where we are working with countries to say, how can we use space data to help you with the problems you might have in your country? So, for example, in Kathmandu, our Servir office helped a lot after the earthquake in identifying where there had been landslides to help out with rescue workers going around trying to help people after the earthquake. So our Servir office in Kathmandu, you know, again, we're trying to say, how can we take space data and help with problems right here on this planet? The other thing that we have is a program that anybody can help us at NASA. You can find it at nasa.gov/solve. That's just SOLVE. And we have all kinds of fun, what we call citizen science projects, where you can help us identify stars that might have planets around them. You can help us map Mars. There's all kinds of projects on there where people from all around the world, and I tend to think students you guys' age do the best job, can help us with some of the science problems that we're working on. So everybody can come help be a NASA scientist if you go to nasa.gov/solve.
Okay, all right. One question here from Mr. Soft Skills Group was, where did the water actually come from? I mean, how did it end up on Mars? Was it always there?
That's a great question, and scientists are actually still arguing about that. Planets are made of two things. They're made of they were made of material that was around at the time the solar system formed about 4.6 billion years ago. That material is preserved today, and we can study it in comets and in asteroids. So for a long time, people assumed, since comets are made mostly of water ice, people assumed that the water on planets came from comets. Well, as we've been able to study comets, including with Rosetta, we've learned that water in comets is actually the wrong kind of water. And people kind of say, what do you mean by that, the wrong kind of water? Well, it turns out the exact chemistry of that water is a little bit different than the water that we find on Mars or on the Earth. So now scientists are starting to think that most of the water on planets actually came from asteroids. Now, asteroids aren't made of water, but they have rocks that have water trapped within the chemical structure of the rocks. And we actually think there was enough water in certain kinds of asteroids that that's what brought most of the water to the planet. So the water that's here now on the Earth or on Mars was brought there about 4.6 billion years ago when the planets formed.
Sure. All right, and Mrs. Smith's group, do you want to ask a last question?
All right. Here's our question.
How did the planets in space get in the order that they are in now?
It's the simplest questions that are the hardest questions to know. And that is a great question that we have scientists all around the world struggle with that question. And, you know, when we only had our solar system to study, back when I was in school over 30-some years ago, we had a theory that the way the planets formed was just had to do, you had a young sun, then you had all this material going out from it, and you could kind of say, well, the further you went from the sun, the more the temperature went down, the more the pressure went down. So all of our planets, with the rocky planets close to the sun, the gas giants further out, all of those formed from a pretty simple kind of picture of temperature and pressure changes away from a young star. Well, as we started looking at solar systems around other stars, we realized you could have gas giants, planets bigger than Jupiter, right close up to their parent star. You could have rocky planets really far from the parent star. So other solar systems weren't arranged the way ours are. So people started doing more complicated models, and it turns out not only can planets form in all kinds of different orders than we see here in our solar system, but now we think planets actually move around early in the history of a solar system. We think Jupiter was actually originally closer to the orbit of Mars, and then it moved outward. So how solar systems form and why planets are in the places they're in is really complicated, and it's really cool, and it's fun math and gravity and planets, and you have to do all this cool math to figure it out. It's reason right there to become a mathematician.
That's what I like to hear. So one last question before we close, because I know you've got to run off to another meeting. Let's pretend we find life on another planet, and it happened to be some sort of being. Is there a set of laws governing how you interact with these people, and if they come to Earth, who takes ownership of where they land? I mean, are there people who discuss those sorts of things?
You know, I'm sure there are people who think about those things, but we haven't gotten to that point already. Planetary protection, which I talked about a little bit, is actually governed by international law. There's actually an international treaty that governs protecting other planets from Earth contamination and protecting the Earth from contamination coming, you know, from outside. And it's actually...
But that would be more than international. That would be intergalactic.
Exactly. So we haven't figured that out yet. That's still yet to be done.
Okay. All right. Well, Dr. Stofan, I just wanted to say thank you so much for giving up of your time. I know how busy you are, and I know that your schedule is probably far worse than mine. So we wanted to say how much we appreciate the fact that you gave us of your time to explain all the things that we needed to know, and you answered all our burning questions, and we really do appreciate it, and we'd like to say thank you very, very much. So we're going to ask everyone just to wave and say goodbye. And we're going to end the broadcast here.
Thank you.